Good morning, Assalamu alaikum, and we are now going to start the first session of this training webinar. My name, as you can see, is Khurshid Asnain, and I'm an advisor at Comstech, and I will be moderating this session. So first of all, welcome to all the participants of this training webinar on acquisition, conservation, exchange, and safety duplication of plant genetic resources in OIC member countries for the Asia chapter. This webinar is being jointly organized by the OIC Ministerial Standing Committee on Scientific and Technological Cooperation, which is comstech, the Islamic Organization for Food Security, Iofs, and the Bioresources Conservation Institute, BCI, from the Pakistan Agricultural Research Center, Council, PARC. And this is going to be the first workshop, the first regional workshop of a three-part series, with the other two workshops to be held later this year for Africa and for Middle East and North Africa, as it's called MENA. The first session is an inaugural session which is being addressed by the heads of the three organizations which are organizing this event, and the later sessions today and tomorrow will concentrate on the technical aspects of the program. Before going further, let's have the formal opening of this activity with the recitation from the Holy Quran.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الرحمن علم القرآن خلق الإنسان علمه البيان. الشمس والقمر بحسبان والنجم والشجر يسجدان. والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان. صدق الله العظيم.
Welcome back once more. And let me introduce to you the organizing and technical committee of this program, this workshop. This includes Dr. Ismail Abdul Hamid from the Director of Programs at Iofs, and Ms. Makbal Bulatova from Iofs, Mr. Mohammed Jamil and myself and our IT team from comstech, and Dr. Sadruddin Siddiqui and his team from Bioresources Conservation Institute of Pakistan. As you will have seen, this two-day program includes speakers from different geographical regions from Asia and beyond, from Malaysia, Pakistan, Oman, Turkey, Kazakhstan, Azerbaijan, Tunisia, and Islamic Development Bank. as well as Saudi Arabia. We are deeply grateful to all our respected speakers, resource persons, for sparing us the time and effort, and I'm sure we will all benefit very much from their knowledge and their experience. Let me say a few words about the background to this event. As of course, I'm sure all of you experts and participants are aware that food security is one of the paramount concerns for all countries, particularly in the face of burgeoning populations and the need for adequate nutrition and the grim climate change scenario which confronts many of the countries in the OIC region and of course in the entire world. We are all acutely aware that these challenges can only be met by coordinated efforts of the countries by cooperation to preserve our existing plant species, to expand and to exchange the genetic materials between the countries, and to have a overall expansion in our bioconservation and our genetic pool. And finally, and not a small matter, how to integrate these new species into our food stream and into our genetic pool. And it goes without saying that the establishment, organization, and functioning of gene banks constitutes the backbone of this exercise, which is, of course, the theme and topic of this workshop, that is to develop the capacity of our member states. Some of our member states have well-developed human and technical resources for the development and organization of the gene banks, while many others lack in this regard and there's a serious need to build their capacity for the organization of the gene banks and the technical resources needed for it. The OIC itself is very seriously aware of this matter, and in various resolutions of the OIC, whether in the Science and Technology Summits or the Council of Foreign Ministers or the annual coordination meetings, we have been made aware of the seriousness of the problem of social security, as well as the nutrition to meet the needs of our children and our populations. And so both the Iofs, which is of course mandated by the OIC to look into the affairs of food security, as well as comstech, which is mandated to look in the technical aspects of scientific and technological cooperation. We are both engaged with these issues in our own manner and our own domains. We have conducted several trainings and workshops and data collection exercises and the formation of the plant genetic resources working groups of member states, and we have at least a group of 5 countries which are actively participating and cooperating in this matter with comstech, and I'm sure many others are working in cooperation with the Iofs. And the hope and the effort, as you are aware, there was another initial exercise or workshop organized by the Iofs in a virtual workshop organized with the help of the UAE government in July last year, which also focused on the aspects relating to the development of regional gene banks. And so the present workshop is a continuation of the earlier effort, which is in words to build the capacity for the various aspects related to the acquisition, conservation, and exchange of the plant genetic material in the OIC member states. So as you have seen the program, it has a number of experts from various domains of this problem, of this challenge of developing the capacity of member states in the different aspects of plant genetic resources, development and integration. And those aspects will be covered in the technical workshops, technical lectures in the next session. We will also be having presentation from the Islamic Development Bank tomorrow. Maybe they will also be able to share with us There's a videos documentary of their efforts. As you all know, the Islamic Development Bank is also playing a very key role in supporting various projects in different countries, which relates to food security and nutrition. And besides that, we will also be playing the documentary about the National Gene Bank in Pakistan to complement, to further inform you about how we are addressing this. We'll also be having a documentary about the various activities of comstech. So with this introduction, I would now go on to the first item of our agenda, which is the welcoming remarks and the opening speech by His Excellency Mr. Jarlan Ibn Daulat, the Director General of the Iofs. Unfortunately, His Excellency is elsewhere also committed at this moment, so we will be playing his recorded video speech on the occasion. So the speech of Mr. Jarlan Ibn Daulat, DG of the Iofs.
Bismillahirrahmanirrahim. Your Excellency, Professor Muhammad Iqbal Chowdhury, Coordinator General of the Ministerial Standing Committee on Scientific and Technological Cooperation of the Organization of Islamic Cooperation. Dr. Muhammad Azim Khan, Chairman of Pakistani Agricultural Research Council. Assalamu alaikum wa rahmatullahi wa barakatuh. Distinguished participants, first and foremost, I would like to convey my gratitude to the OIC General Secretariat and member countries for unwavering support given to Iofs, reflected in the final Abu Dhabi declaration of the second OIC Summit on Science and Technology. I also would like to extend our appreciation to Professor Muhammad Iqbal Chowdhury, the Coordinator General of Comstech, for the institution's ongoing valuable contribution to the scientific and technological growth in OIC region. It is crucial to note that the Iofs and Comstech have signed a memorandum of understanding and adopted a joint action plan to implement joint activities and potential projects for the benefit of OIC member countries. Agrobiodiversity is becoming increasingly important in the conservation and use of genetic resources for the formation of sustainable agrosystems. This is due to the current situation of food security around the world, namely declining crop yields, water and energy shortages, environmental degradation and climate change, as well as the constant growth of the world population. Despite the fact that the leading countries of the world are actively working to conserve genetic resources as well as in the provision of farmers with the modern varieties and seeds, the situation in the OIC countries is quite challenging. The establishment of cooperation and network among gene banks in OIC region should be strengthened and coordinated with availability of exchange of accessions. It is known that all countries need to reserve its genetic resources in accessible and available status and to be molecularly characterized. These technologies need to be developed in a suitable manner in OIC member countries. Keeping and developing our genetic resources in a proper way is our gate to food security. In this regard, our institution works on the implementation of development of National Gene Banks program, the aim of which is to strengthen OIC member countries' capacity to conserve and reproduce plant and animal genetic resources by developing partnerships among countries that would help in getting best practices and keeping up to date with the new technologies. Today, the Iofs, Comstech, and Pakistani Agricultural Research Center, PRC, are conducting hand-in-hand training to achieve a vital goal, to convene eminent specialists from OIC member countries to debate biodiversity and plant genetic resources related concerns and challenges by assessing countries' current practices and technologies. Analyzing each country's approaches would provide us with a realistic understanding and vision of efficient program realization. The Iofs, comstech, and PRC also plan to continue organizing such training for other OIC member countries in the following months, concluding with the international forum, with participating of all attendees of the training and invited international organization in late November 2021. It is my fervent hope that the outcome of these trainings would result in the establishment of viable sectorial platform for cooperating among OIC member countries, opportunities for sharing and exchanging experiences, and the generation of initiative and value-added knowledge among countries and organizations. I wish this training fruitful deliberation and successful outcome. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you very much to the Director General of Iofs, Mr. Yarnan Bedolat, for his enlightening and supportive opening remarks. And now we have the next speaker, His Excellency Professor Dr. Muhammad Iqbal Chaudhry, the Coordinator General of Comstech, who will be addressing this workshop. And the title of his dispensation is Role of Agriculture in the Economy of OIC Member States. Professor Iqbal Chaudhry.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Good morning and good evening, as we are in different time zones, and certainly an extremely important occasion for us. And I would like to congratulate His Excellency Professor Yarnan Bedolat, Director General Iofs. We have representative of Iofs in front of us. We also have representative of Pakistan Agriculture Research Council, and equally important, my very dear colleague, Professor Dr. Khurshid Hasnan, who has played an extremely important role in putting together this very important event. We all understand in the context of Islamic Summit on Science and Technology in Abu Dhabi, in which the Abu Dhabi Declaration has emphasized the need of development in agriculture and food security as the integral part of the well-being of Muslim Ummah. It has also been identified as one of the key areas of cooperation between the OIC member states. The declaration also gives fresh mandate to comstech and Iofs to work together in the area of food security, and therefore to achieve that very important objective, which is part of Science and Technology Innovation Agenda 2026, which was approved in Astana, Kazakhstan. Ladies and gentlemen, agriculture is extremely important for us. We all understand that it plays an extremely important role in the livelihood of everyone, as well as it has a strategic dimension that food security is now considered to be as important as the national security. And we all understand that agriculture would remain a very important component of national development and security. We all understand that the vast land of OIC member states, 1.38 billion hectares, provide us opportunity of using that land resource for the production of value-added agriculture product. At the same time, over 50% of the population of many OIC member states are associated with agriculture. So it is important in terms of food security. It's also important for the livelihood of large majority of our population. We, in the OIC member states, we grow a whole range of different products. And these crops include from barley to cassava, from wheat to rice, from palm oil to maize and coffee. And these are all extremely important because not only they are consumed by the local population, but also provide an important export earning for many countries. Within the OIC countries, we have several countries who have major uh, agriculture produce that include Turkey, Indonesia, Pakistan, Bangladesh, Egypt, and Nigeria. And many of these countries have actually excelled in the field of agriculture. Overall, as we understand, OIC has done pretty well in the field of agriculture, but there is a decline in agriculture productivity over the years, and that is a pattern which we see globally, and that could be associated with the structural transformation, agriculture market instability, environmental stresses and depletion, degradation of land and water resources, which are global problem related to climate change and other factors such as urbanization and population growth. In terms of agriculture production index of OIC, countries have recorded a comparable performance as compared to non-OIC developing countries. Food security, ladies and gentlemen, is extremely important component. It is a basic need. It is important in terms of eradication of hunger and malnutrition and making households more food secure and basic human right protected under different international conventions. So hosting almost 175 million malnourished people, the challenge of food security in OIC countries has an extremely important dimension and is a very important challenge for the overall development trajectory, both in terms of short terms and long term. Food security is directly affected by factors including but not limited to difficult economic conditions, weak commodity prices, lack of adequate infrastructure, poverty, conflicts, adverse climatic conditions, and several other factors. The unprecedented COVID-19 pandemic has also affected agriculture sectors like other sectors of economies. Climate change is an important factor which affects agriculture more than any other sector. And as a result of it, we see a two-way feedback effect. Agriculture has a large footprint on environment. At the same time, it is one sector which is affected with the environmental changes and climate change more than any other sector. So there is a linkages between the two of it. There is an organic relationship, more agriculture, more footprint on climate. At the same time, agriculture is affected from lots of climatic changes. And that demands a smart agriculture that required climate smart agriculture. For that, there is lots of science and technology and engineering input which is required. Biodiversity and gene bank has been extremely important. This initiative of joint initiative of Iofs and comstech for the establishment of gene bank, which has been successfully led by my colleague Dr. Rashid Hasnan, is an extremely important program. In view of the need to promote global food production to cater for the estimated population of 9.8 billion by 2050 within a persistent food insecurity situation, it is important that we work towards cooperation in various disciplines of agriculture, uh, including achieving food security by applying the modern method of genetic engineering and other ex situ collection methods. So in this regard, the importance of pooling resources in the area of conservation, sustainable use and exchange of plant and animal genetic resources for food and agriculture among member states of OIC cannot be overemphasized. This is considering the organic relationship between sustained food security and biodiversity and the various challenges faced by most OIC member states, ranging from increased uh, food deficit, low investment in agriculture, economic and political crisis, natural and man-made disasters, poor and depleted infrastructure, and other agriculture production issues. That is where we need to work together in a very coherent and systematic manner. Accordingly, the protection of biodiversity and the management of plant and animal genetic resources through ex situ conservation, sustainable use, and exchange would address the major requirement for innovation and scientific paradigm shift with regard to food production and food and national and nutrition security. The development of national gene banks in selected OIC countries is an extremely important milestone in which we all have interest and a stake. That can only be achieved through coordinated efforts by member state with the sense of urgency. In order to realize the objective of food security for teeming population of member state, there is a need of inter-Islamic cooperation, cooperation between organization and nation states. Pakistan Agriculture Research Council is an extremely important organization with the capacity to help in the establishment of gene bank. And Iofs and comstech can work together to use this important resource of helping the other member states. This is where we find there is a need to address hunger and poverty in an integrated and holistic manner. It requires relevant OIC institution to benefit from the occasion of workshop to create an enduring cooperation with the production of plant and animal genetic resources to prevent their progressive erosion and meet the challenge of food security. Similarly, regional and international cooperation must be intensified to ensure that OIC member states contribute meaningfully to ongoing partnership for ensuring food system resilience. In the context, I would like to say that comstech is aware of the importance of food security and nutrition issues with respect to OIC member states. We also appreciate the key role which Iofs has to play. And in this context, we have conducted a number of activities since 2017 that have led to the formation of a working group on plant genetic resources, which is currently working on a joint project, both on preservation of existing varieties as well as integration of new varieties in the food system. In the light of the need to counter the challenges of climate changes, drought and salinity and their effects on crop, we have conducted several conferences and workshops to introduce new breeding technologies among the member states. We've also initiated steps for increasing the focus on biodiversity and have enabled interested member states to become partners in this global pursuit. The present workshop is an expression of the commitment of comstech in partnership with the Iofs to develop the capacity of member states in the science and technology of gene banks so that each may develop its own facility and capacity to maintain them. This is the first of a series of 3 such training workshops which we are jointly organizing, each focused on one particular region of OIC namely Asia, Africa, and Middle East and North Africa. These workshops, I'm sure, will go a long way in imparting knowledge and developing capacity, both individual and institutional, towards the protection, conservation, and exchange of plant genetic material between the member states. I sincerely hope that it will lead to creating a permanent framework for cooperation among member states with a view to supporting local, national, and regional actions and collective responses on the sustainable use of plant genetic resources for increased agriculture productivity and sustainable food and nutritional security. With this, I would like to emphasize that such events need to be followed by concrete action. Professor Khurshid Hasnan has been working very diligently to follow up, and he has been interacting with many institutions. So my request to all the participants would be to kindly interact with Dr. Khurshid Hasnan. So he, with closely with our partner Iofs, can take them to the next level and then realize most of what we have been looking for. I would like to wish you a very successful event and looking forward to see the recommendation of this event very soon, inshallah. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you very much, Professor Iqbal Chaudhry, Coordinator General Comstech, for your very comprehensive and encouraging remarks about the efforts of Comstech and Iofs both, and about the need for continued cooperation between our institutions. And I'm sure under the dynamic leadership of both of these institutions, Comstech and Iofs, we will be able to achieve our goal and our ambition of establishing regional gene banks and further enhancing the capacity of our existing gene banks for more secure plant genetic resources, preservation and integration into the food system. So we will, of course, in coming years, under your leadership, work towards achieving these goals. Thank you very much. Now, before I call upon the next speaker, let me just again praise our participants of the participation in this activity. We have registered participation and online participation from 13 countries at the moment, spanning the extent of the OIC member states in Asia. We have from Azerbaijan, Bangladesh, Indonesia, Kazakhstan, Malaysia, Nepal, Oman, Pakistan, Rwanda, Saudi Arabia, Turkmenistan, Turkey, and Uzbekistan. So we welcome all of the participants once again, and I'm sure they are listening intently to the knowledgeable discourse from our various participants. The next contribution to this opening session is from Dr. Muhammad Azim Khan, the chairman of Pakistan Agricultural Research Council. Dr. Azim Khan has been called away at the last moment by his duties, but on his behalf, Dr. Sarfraz Ahmed, the member Natural Resources Division, will read out the statement from the chairman of Pakistan Agricultural Research Council, and the title of his presentation is Importance of Plant Genetic Resources in World Food Security. Mr. Sarfraz Ahmed, on behalf of the chairman, PARC.
Thank you, Dr. Thank you, Dr. Assalamu alaikum and good morning to all the participants and members from different countries. First of all, I highly appreciate the effort of Comstech and Iofs for organizing this very important seminar on plant genetic resources and its importance. On behalf of Dr. Muhammad Azim Khan, I read and quote, Honorable dignitaries from Comstech and IOFS, respected participant. Assalamu alaikum, good morning. It's my privilege to address you on inaugural session of training webinar on acquisition, conservation, exchange, and safety duplication of plant genetic resources in OIC member countries, Asia chapter. First, I would like to welcome all the participants from OIC countries who participate in this important training. I am glad to see that this training has brought together the leading scientists from OIC countries to share knowledge and experiences for future strategic planning. Plant genetic resources have an important role to play to ensure food security. Agriculture and food production today is faced with many challenges such as climate change, land degradation, increasing human population, and biodiversity loss. The plant genetic resources have played very important role in development of crop varieties and are still widely needed by plant breeder for ensuring resistance to diseases and pests and adaptation to environmental stresses, climate change to ensure food security. The conservation and sustainable use is necessary to ensure crop production and to meet growing environmental challenges and climate change. The erosion of these resources poses a severe threat to the world's food security. The decreasing dietary diversity and extensive reliance on few major crops like wheat, rice, and maize for nourishment results in malnutrition, especially in case of poor people who have limited access to other resources of nutrition. It is now being realized that in addition to improving crop yield, food security also depends on diversification of food items. Crop genetic diversity is critical for feeding humanity, for the environment, for sustainable development. Given the innumerous interdependence of countries and generations on this genetic diversity, the loss of crop genetic diversities causes critical socio-economic conditions. Countries are fully interdependent with regard to plant genetic resources and in particular for crop genetic resources. As we all know that food is the basic necessity and its availability, access, sustainability, and security is needed for human life. Food and agriculture production are dependent on genetic resources domesticated elsewhere and subsequently developed in other countries and regions. Continue access to plant genetic resources and a fair and equitable sharing of the benefit arising from their use are therefore essential for food security, especially in the present scenario of COVID-19. The world suffered the impact of COVID-19 pandemic, which is putting additional pressure on already fragile eco-economic situation. Keeping in view the pivotal role of plant genetic resources in crop improvement, Bioresources Conservation Institute, formerly known as PGRI, was established at NRC Islamabad in the 70s and enhanced to modern facility with the technical and financial assistance from JICA to initiate collection of germplasm and to conserve plant genetic resources for sustainable utilization. The National Gene Bank Pakistan BCI maintained more than 42,000 accessions of various indigenous plant species collected from different agroecological regions of Pakistan and that required also from abroad. The National Gene Bank of Pakistan distribute more than 12,000 accessions annually to researchers from public and private sector, academia and research institute for research and development. I highly appreciate the important role of Bioresources Conservation Institute, particularly the National Gene Bank of Pakistan for conservation and sustainable utilization of plant genetic resources targeted towards food security in Pakistan. Indeed, this training will provide an opportunity to note where we stand and to plan where we must go. It will help the participant to enhance their understanding on conservation and research on plant genetic resources. It will also help to better understand the issues of conservation of plant genetic resources. I do believe that your engagement in this training will further strengthen collaboration among OIC countries, and that the outcome of two-day deliberation will be helpful for enhancing the food security in OIC countries. On behalf of PRC, I assure you that PRC is ready for any future collaboration for enhancing the genetic resources, conservation, and effective utilization in Pakistan and elsewhere for ensuring the food security and to meet the climate challenges requirement by enhancing the climate resilient crop varieties development also. With this, I am highly thankful for all you for your participation and arrangement of this very important event on this workshop. Thanks a lot.
Thank you very much, Dr. Sarfraz Ahmed, for reading out the important message of Dr. Muhammad Azim Khan, the Chairman, Pakistan Agricultural Research Council. We're very grateful to the PARC for their support and their technical support as well as their advice, which has been a very important part of organizing this program, and it wouldn't have been possible without all the technical input and support that we have received from the PARC and the NARC. And we look forward, of course, to further cooperation, continuing cooperation with the PARC and the NARC in the programs of comstech and the Iofs. Thank you very much. And now we come to the end of this program, this first session, and I would request my friend and my brother, Dr. Ismail Abdul Hamid from the Iofs, the Director of Programs and Projects, to not only thank the speakers of this session, the distinguished speakers in this session, but also to share with us his thoughts on this activity and the future programs that he envisages from the Iofs side about the continuing need for food security and gene banks. Dr. Ismail Abdul Hamid.
Bismillah ar-Rahman ar-Rahim. Thank you very much, Professor Khurshid Hassanin, for giving me the floor. First of all, it is an opportunity for me today to be among all my colleagues, my professors, the eminents, and every one of you today. First of all, I would like to thank so much, appreciating the presence today with us, Professor Muhammad Iqbal Choudhury. It is a very long, always being in cooperation and in discussion, and the harmony between comstech and Iofs. It is not coming out of blue. It is coming from the heart of the people working in two organizations that they want to link hands and to work together for the importance and for the prosperity of our Ummah and our OIC member countries. And today is a clear example for how the cooperation can be done softly, easily, although a lot of efforts have been done. And in this case, we are highly appreciating all the effort that our His Excellency DG of Iofs, Mr. Yerlan Baydawlat, have done during all decisions of our cooperation. I would also thank Ms. Makbal. She is also have been harmonizing this effort. Actually, from comstech, we have been in collaboration for the last 3 months to make today possible with Dr. Sadruddin, with all our colleagues and the brothers in comstech. Today, as it is clear, will be a series of training workshops, and we are planning to have another 2 training workshops to cover all OIC member countries, with the all hope to be gathered in a more wide and OIC forum for the training today. In Iofs, really working with comstech, the sky's the limit. Everything is open for cooperation, and it is really very positive, always ideas. I have to thank from my deep heart to all our colleagues again from comstech, and I also get this opportunity to thank all of our participants today, and we wish for them a very fruitful training, and also to be participating actively in the discussions. And we are all in the same boat, and we need to conserve our genetic resources, as we all know that there is no food security, no fighting for hunger. We could not achieve all what we need in 9 harvesting seasons unless we have a very good and excellent way to reserve our genetic resources. And if you allow me, Dr. Professor Khurshid Hassanin, that if we can take, we can ask all our participants to open the camera, and we can take virtual group photo before we proceed. The floor is yours.
Of course.
No, not now. Yes.
We'll pass on your request, Mike. Please, all the participants can open their cameras so we can see them, and so this way we can have a virtual group photograph of all the participants. So can you please open your cameras and so that we can have you on the screen? So screen share. Still not getting there. I think our IT people are working on this while they work on it.
Yeah, okay, yeah, maybe.
Let me just, while they're working on it, let me just make this announcement that the next item of this session is a documentary video about the National Gene Banks of Pakistan and the National Agricultural Research Committee Center, NARC. So we will be showing you this few minutes documentary in the meantime. Are we able to? Okay, we are getting now people on. Can other people also open their cameras so we can have this virtual photograph, group photo?
Yeah.
Okay, we are getting people now. That looks good. After the group photograph is over, then we will switch to the documentary video about National Gene Banks of Pakistan.
Do it.
If anybody else has forgotten to open their cameras, please do open them. We will be trying to get a picture of the group photograph of all the participants. Yes. Mike, do you have a camera over there to take the picture? we can take a screenshot. Up screenshot. Okay, I think if everybody is ready, we will proceed with the screenshot of the participants. Take one minute.
Second page we put camera.
Anybody else wants to open their camera, please do on the page 2 of this screen. We have only 2 people here with the cameras on. Yeah, please turn on your screen, your cameras. Okay. Yes, some more. Yes, please turn on your cameras if still there are people who haven't opened cameras. So we will take your screenshot as soon as.
Very good. Yeah. Very, very good. Yeah.
Please turn on your cameras. We still have many people who have not done that. We will just wait for 1 more minute and then we will take this screenshot. This is the final call for those who haven't turned on their cameras. We are now going to take the photograph for as many people as we have on this screen at the moment. Okay. Let's go ahead. Okay. Thank you very much. We will probably, if they later add some session again, we will try and get the remaining people their pictures. So that's the one part of the activity. So now we would like to play the documentary video about the National Gene Bank of Pakistan and the NARC. As you know, the Pakistan National Gene Bank is a very well-developed and active gene bank which has a fair amount of acquisitions and experience. So I'm sure you will enjoy looking at their presentation. Please go ahead. Pakistan Gene Bank.
The National Agricultural Research Centre is the largest of all the in-house research institutes of Pakistan Agricultural Research Council. Since its establishment in 1984, it has evolved as a multidisciplinary and target-oriented centre of excellence for all agricultural research. The NARC serves as a platform for jointly implementing the national research plans in collaboration with other federal and provincial agricultural research and academic institutions. Located near Raval Lake, the center spreads over 1,400 acres, including experimental fields, research labs, and supporting infrastructure. Headed by Director General, the center comprises of 18 research institutes to solve the emerging issues of national importance. New knowledge and innovation are developed in all agricultural disciplines, including plants, animals, national resources, farm machinery, and social sciences. Historically, the scientists working at the center have contributed to major R&D initiatives undertaken by National Agricultural Research System. The National Gene Bank of NARC plays a critical role in acquisition of germplasm from national and international sources and its distribution for crop breeding programs across the country. It maintains a collection of more than 35,000 accessions and annually distributes more than 12,000 accessions nationwide and worldwide. The commodity programs of wheat, rice, maize, fodder, pulses, oilseeds, and sugar crops have contributed in continuous evolution of new cultivars in close collaboration with provincial research system. The scientists of NARC also developed more than 44 varieties and 11 hybrids since 1990s. Being a part of CGIAR system, the NARC scientists developed and promoted a number of production technologies for various crops like zero tillage and bed planting in wheat, direct rice seeding, mechanical beet planting, chemical weed control in pulses, mechanical planting and harvesting of canola and soybean. As a result, sustainable increase in productivity and food security goals are achieved. Realizing the enormous potential of horticultural sector, NARC is specially focusing on development and promotion of high-yielding varieties of fruit, vegetable, and ornamental plants. NARC is a pioneer in introducing and developing production technologies for strawberry, grapes, olives, tissue-cultured virus-free bananas, seed potatoes, and protected vegetable production. The center is making conscious efforts to promote highly nutritious and safe vegetables through rooftop and kitchen gardening. The center is also developing recipes for value addition of fruits and vegetables to provide nutritious, pure, and quality food products with extended shelf life. The agricultural engineers of the center have developed more than 30 new machines for planting, conservation tillage, harvesting, threshing, seed cleaning, fruit picking, grading and processing operations. Main machines developed include olive oil extractor, sisal decoratator, turmeric dryer, mango hot water treatment plant, turbo disc, fertilizer band placement drill, weed straw chopper, and happy seeder. The center have developed environmental friendly technologies to reduce crop losses caused by major pests and diseases by identifying sources of resistance and their utilization in developing field and horticultural crop varieties. This initiative led to the development of more than 100 wheat varieties in the country, thereby preempting rust epidemic since 1978. The center houses National Insect Museum and National Herbarium, where more than 112,000 insects and 100,000 plant specimens have been preserved for reference. The center is applying both conventional and advanced biotechnologies to address the challenges in crop production, especially in wheat, cotton, groundnut, potato, and tobacco. The center has established a credible reference biotechnology laboratory for DNA fingerprinting and detection of GMOs in food items to promote international trade. In the livestock, poultry and fisheries sector, main focus lies on improvement of breed, health and nutrition. The center has introduced least cost ration formulation of silage bale production, embryo transfer technology and ornamental and channel catfish culture in the country. The center is also playing a leading role in surveillance and control of important animal and avian diseases. NARC is maintaining an ISO-accredited SARC regional diagnostic facility for avian influenza. The center has successfully eradicated rinderpest and bird flu from the country. The center has done pioneer work in managing limited available water through dissemination of innovative irrigation technologies, including sprinkler, trickle, furrow bed system, and diversions, conveyance, and application structures for rod cohi system. NARC has also taken a lead in designing and disseminating alternative energy resources such as solar, wind, and biogas energy for tube well operation and high-efficiency irrigation systems. By applying geoinformatics, NARC has developed an inventory of glaciers and glacial lakes and has also mapped resource characterization of rod cohi areas in Pakistan. Realizing the water scarcity and environmental pollution, the center has developed a bioremediation technology to reclaim domestic and industrial used water for irrigation purpose. The model is being successfully implemented at national and regional levels. Rangeland improvement technologies are also being developed involving silvopastoral and dryland afforestation techniques. The center has developed and introduced which revolutionized beekeeping as a cottage industry. Besides refining the honey production technology, NARC scientists also created a skilled workforce of more than 9,000 beekeepers, boosting the honey productivity from 4 kg to 25 kg per hive. A kit for testing honey quality in the field has also been developed for bee farmers. Social and life scientists of NARC interact closely to identify researchable problems of farming communities for translating them into research priorities, plans, and seek socially, economically, and technically viable solutions for them. The knowledge and technology generated at the center are disseminated and upscaled for wider application of national level, for which mass media tools are also employed. Agricultural messages, documentaries, and programs on current issues and area-specific production technologies are produced and telecasted on TV channels. The center has one of the largest websites on agricultural research and development in Pakistan, with more than 550 web pages and 6 online databases. The Urdu section of the website is especially designed for farmers. Demand-driven and need-based, market-oriented, short-term capacity building and vocational trainings in crops, horticulture, fisheries and livestock are arranged throughout the year for diversified clientele including scientists, extension workers, students, farmers, entrepreneurs and service providers. Exposure visits are arranged for planners, lawmakers, foreign delegates, diplomats, visiting scientists, farmers and NGOs to share development experiences for redirecting research agenda accordingly. Technologies and products are displayed at agricultural fairs and exhibitions for creating mass awareness. Besides accepting interns from universities across the country, the center also offers MPhil and PhD degree programs in emerging fields of agricultural sciences such as plant genomics and biotechnology, animal genomics and biotechnology, plant and environmental protection, applied economics and national resource management. To keep pace with the world's ever-growing knowledge, the National Library of Agricultural Sciences has about 2,7,500 books and 1,036 research journals. NARC feeds the scientists of entire NARS for consistently updating them in their respective specialities. The center is also publishing a peer-reviewed quarterly journal and monthly technology reporter. Besides pursuing traditional approach, NARC also follows innovative pathways for fast-track transfer of science-based agricultural products to end users, especially to the farming communities, through PARC Agritech Company. Some of the products of NARS are also being showcased at NARC Technology Display Center. NARC is committed to serve farming community and bring prosperity and food security through research and development.
Thank you very much for that documentary about the National Gene Bank of Pakistan. And with that, we basically come to the end of the inaugural session and its various activities. And now we come to the first technical session of this training webinar. And this technical session is titled Overview of Plant Genetic Resources and Gene Banks. And this session is a 2-hour session, and it has a different session moderator, Dr. Ismail Abdul Hamid of the Iofs, with whom you have been introduced. And so I will now hand over the moderation and the content of this session to my colleague, Dr. Ismail Abdul Hamid from the Iofs, and request him to introduce the various speakers in this session and the poll that will be taken in this session. So over to you, Dr. Ismail Abdul Hamid.
بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Thank you very much, Professor Khurshid Hassanin, and it is an honor for me today to really moderate the first technical session, overview of plant genetic resources and gene banks. And today, actually, we have eminent speakers, and if you allow me, I will give very brief introduction. We have Dr. Sadruddin Siddiqui, and he is a Bioresources Conservation Institute, BCI, National Agriculture Research Center, NAR, Islamabad, Pakistan, and will give us a brief presentation on importance of conserving the plant genetic resources for efficient utilization. And I have to admit the efforts that it was deep and it was very successful for cooperation with Dr. Sadruddin. Actually, it was really a journey, and actually it was very important for us also for tailoring this important program. So I have to thank him in the beginning. We will have, secondly, we will have Dr. Minora Yismibikova, and from the Gene Pool group of Kazakh Research Institute of Agriculture and Plant Growing Kazakhstan. And she will give us an overview of gene bank in Kazakhstan and Central Asia. And our third speaker in today will be Dr. Tariq Rafik. Tariq Rafiki is Dr. Tariq Rafiki is from Plant Genetic Resource Program, and Bioresource Conservation Institute, PCI, National Agricultural Research Center, NARC in Islamabad. We are happy to have Dr. Tariq among us today. Thank you for coming today, Dr. Tariq, and he will give us a national overview of National Gene Bank of Pakistan activities, which we know that it is a very well developed gene bank. Thank you. And also we will have Dr. Ali Lawati, plant genetics, natural and medical science research center, University of Nizwa, Oman. And Dr. Ali actually will give us a plan introduction and quarantine. Thanks for Dr. Ali for coming also among us today. Thank you very much indeed. And then our last speaker who will today will speak about gene bank management in Turkey, standards and challenges. Ms. Sinay Boyraz Tubaloglu, Biodiversity and Genetic Resources Department of Turkey. We are also happy to have this Sinay among us today. If you allow me, we can start our journey today with Dr. Sadruddin Siddiqui from Bioresources Conservation Institute in NARC. And the presentation is about introduction to resource persons and the importance of conservation, importance of conserving the plant genetic resources for efficient utilization. Dr. Sadruddin, the floor is yours.
Bismillah ar-Rahman ar-Rahim. Thank you very much, Dr. Ismail, for introduction. And actually, the purpose of this is information sharing. And we want to develop collaboration and assess what is going in the OIC countries. So, as we know that plant biodiversity is very important, and there is no survival because they are the primary food producers. And if we don't have them, and if we lose them, we lose our food security. So they are very important, and all the food habit and cultural diversity depend on the food that is being produced around the world. For example, Japanese eat a different type of sticky rice, but in Asian sites, we don't eat the sticky rice. We use basmati rice, which is very fragrant, and it is exported to other countries in Middle East and West. So if we want to export rice to Japan, we have to develop the rice they want to eat. So the trade among different countries also depends on what is being produced. So economically, it is a very important to know what diversity we have and what we are producing. So these diversities depend on the genes which reside on the chromosome, and its phenotypic behavior give rise to different type of food, species, crops, and all the diversity is composed of these. That is very important to conserve in the different forms, and seed is one of the form in which we can conserve the diversity. Every single gene is very important. Only one gene difference was found that was responsible for the Green Revolution, and it saved the world from famine. Similarly, the discovery of cytoplasmic immune stability led to the development of hybrid rice production and other hybrid systems. A new plant type could be developed by breeding, which is 5 to 6 feet tall, like a sugarcane plant. And recently, one gene is found with multiple benefit, and it can give higher production up to 82% under salt tolerant and 35% dry weight, higher than to control in drought condition. And when it was rewatered, after 3 days, the plant revived and gave good biomass production. So these genes are very important, and they are contained within the organisms that we have to conserve and utilize them by evaluation and identifying the elite lines with different traits that are incorporated for breeding, and the breeder use them to develop the varieties. For example, in rice also we have identified different elite lines with different traits that can be used to develop good performing varieties under different conditions. So food security depends on this. It's a complex process where germplasm plays the basic building role, and the varieties are released that goes to the farmer. So there are, you can see that in Pakistan, the population of both urban and rural areas is growing very fast, and the production area of wheat was not much enhanced. So it was mainly due to the production in higher yields of wheat that we have been able to feed the ever-growing population. And we are having loss of genetic diversity by selection. So wild species has many genes, and then we had early domestication and we limited the genetic base become more narrow, and the modern varieties have very limited genetic base. So by having uniformity, we can have very great loss. In early 80s, the banana bunchito virus attacked in Pakistan, and 90% of the crop was wiped out because it was only one variety that is being grown in Pakistan. So diversity is sustainability, and monoculture is very dangerous. And there has been many instances in the world, and at least 5 in Pakistan, where great loss to food was and food security was compromised due to monocropping and less diversity. So genetic erosion is being imposed due to improved varieties, new crops introduction, land use change, and disasters. And recently, earthquakes, massive operations in the army operation, and formation of lake. This Atabat Lake is a 25-kilometer area lake, which was first a terrestrial environment, and now it is an aquatic environment, and all the biodiversity there has been lost. And now the COVID-19 has also affected this agriculture. So climate change is there with extreme events. For example, now we are seeing snowfall in deserts where there was no snow before. And it could be enjoyable for some people, but maybe problematic for many situations. And in heat wave last 2 weeks before in Canada, and it was causing much deaths. And it is very 126 years record was broken. So the climate is seriously picking up. If you have the resources, you can manage. But in situations where resources are limited or scarce, there could be problem. So flooding is also, Pakistan is now the 5th most vulnerable country to the climate change, and the agricultural land is degrading, and billions of rupees worth agricultural produce is being lost. And research institutes are also suffering, and the material they have is being lost. So we need to conserve both. In 2012, we were growing the germplasm at NARC, and we have, because it's a cross-pollinated crop, brassica, we covered the flowers to get pure seed, and there was a hailstorm, and all the 1,000 accessions that we have planted, we lost that year. So we need to protect them. And overall, this is a study of 80 years from America, and they have found that 93% genetic diversity of the cultivated species has been lost with them. So at this precedented rate, how the living planet will sustain the sustainable development goals has been outlined, and many of them directly relates to the food biodiversity. So what conservation strategies there is in situ, that is in their own habitat, and ex situ conservation. So we will discuss only the ex situ conservation and mainly the seed gene banks. So germplasm that is used for crop improvement is with the researchers and gene bank, and the germplasm that is for food production, for fiber, medicine, etc. It is with the seed companies, public and private, and farmers. So gene bank is an organizational unit that manages the collections, conservation, and facilitate its use to the breeders and other researchers. There are more than 1,700 gene banks in the world. And the objective is mainly exploration, collection, biodiversity from diverse ecologies, serve as the national facility for conservation and supplying the germplasm after evaluation, documenting its information and genetic knowledge, and creating awareness among the different stakeholders. So this is the different laboratories and the building and the gene bank of Bioresources Conservation Institute and the National Gene Bank of Pakistan. There we are conserving into 3 different storage conditions. The short term, which is the active collection from which we distribute the seed and also perform the evaluation. It is at plus 10 degrees Celsius, 8 to 10% seed moisture content. Theoretically, we can conserve the material for 25 years. The medium term conservation at 5 degrees centigrade for 50 years, and the long term at minus 20 degrees centigrade in the freezers. And of course, we are also doing safety duplication. So we have conducted about 145 expeditions in different ecologies of Pakistan. And since no country is self-sufficient in genetic diversity, so we have to acquire material from abroad, and we have done from different countries. And for this, we have to have linkages developed and collaborate with different organizations, institute, nations to get the germplasm and exchange, and also see that what are the laws and international treaties through which we can do, like International Treaty for Plant Genetic Resources for Food and Agriculture, and there how we can put the material into the multilateral system and work for the excess benefit sharing. So we have about more than 42,000 different accessions of different categories, mostly We have cereals and oilseed, legumes, vegetables, powdered fiber, medicinal aromatic plants, fruits, other wild species, crop wild relatives, and fodder. And we distributed varyingly 10 to 12,000 accession, but in 2019, it was about 8,000 samples we distributed, and that dropped to 5,000 last year because of the COVID. And we are doing our safety duplication at this Svalbard Global Seed Wallet in Norway. The material that is without seed or is vegetatively propagated is being conserved in this vitro, and we are also having feed gene bank. For data management, we were doing the on Excel sheet, but now we are transforming toward the open source genetic database with Grain Global. So there is choice to design and develop your own or use open source. So we have opted to use the open source database. So there are different policies that are required for PGR, the community rights for collection, germplasm, the conservation policy of material, which material we can conserve, and distribution policy, the material transfer agreement or standard material transfer agreement, distribution policy that we want to give to private or only public sectors, bilateral exchange, how much material we want to put in the multi-lateral system of international treaty and international property right, non-business rights, and safety duplication. All these things have to be decided. So under the current pandemic scenario and the global restrictions which can arise also again, and it has not gone yet, but can be more severe. So we have to develop national gene banks as well as safety duplicate gene banks of the OIC countries. So that it is in excess of the, when needed, the material. And establishment of community seed banks for the farmers, so that the farmers, when they plant the seed, they have in reserve some seed for the next cropping season. And if they lose their seed, they can use their reserve seed from the community seed banks, and they can provide and play their role in the food security. So this is all from my side. I hope that it was very clear.
Thank you very much indeed, Dr. Sadruddin Siddiqui. It was very important for us, and we have to take some notes. We will share it at the end of our session also. And now, if you allow me, dear participants, actually, we have now 5 minutes for, we call it a poll 1 to 7. So what it will going to be in these 5 minutes, you will have in your own screen now, we will have a list of polls, and this is a questions of the poll will be appear now for you, and they will then you have to select the possible what is suitable for you. Then when you select it, you just click next. Then you select what is suitable for you, and next. Then in the end, you will have in the end of the 7 polls, you will have to click submission. And then we will have also again to remind all of you about the questionnaire to your country, and we will later request before the end of the day also to share this questionnaire. So it should be also this questionnaire also have to be also shared during the day. So as you can see now, this is the number 1. It's please just choose one from each category and press next. Dear participants, please choose the suitable for you. job description, job category, participation status, affiliation. Kindly, all participants, please try to participate in this polls. It's very important for us. Yeah, we still lag behind. Actually, we need all the participants to really give us participate in the polls. This poll is very important. And when you're done, just click submit. Dr. Ali will try to see what is the chat. And Dr. Ali is not able to interact with the court. Maybe our colleague from the state part, maybe.
Let me explain, Dr. Ami. Dr. Lavati is not able to interact because he is a resource person.
Okay.
The poll is only for the non-speakers and the non. We already have his data with us. So, Dr. Lavati, if you're hearing me, there's no problem.
It's clear now. Yes. We have participants 31 only is contributing, so we still need more than 38% is still not participating. So it means it's done now. Dr. Porsche, it means that it's okay now or still ongoing?
Ismail, you can start the proceedings. The polls are finished, closed now.
Okay, thank you. So we can proceed now for our next speaker. Thank you for participating, and we are also reminding for the questionnaire to be ended before the end of the day. So our next speaker is Dr. Minora Ismibekova, and she is from GPOL Group of Kazakh Research Institute of Agriculture and Plant Growing. And Dr. Minora will give us an overview of gene bank in Kazakhstan and Central Asia. Dr. Minora, the floor is yours. Dr. Minora.
I see.
Dr. Minora, please.
Just wait a minute. We are trying to sort it out. The problem.
Okay, so we move. What?
There's some issues.
She's facing some
issues.
Yeah. Okay. If you allow me, Dr. Minora now is facing some technical problems in her computer. So if you allow me, we will give the floor now to Dr. Tariq Rafiki from from BGR and BCI, and he will give us a national gene bank of Pakistan activities overview. And I know that it's very important for us to know this very important lecture. Dr. Tariq, the floor is yours.
Bismillahirrahmanirrahim. Assalamu alaikum to everybody. Today I will present a video which will explain activities of National Gene Bank of Pakistan. We prepared this video, and I will request comstech team to play the video.
For the sustenance of life on Earth, plants are the most importantly needed entity after fresh air and water. Plants are the primary producers of food.
and medicine, fibers, and related products and byproducts for which sustains the life and the planet is surviving. The biodiversity or variation in plant, its morphological or appearance variation, physiological behaviors or responses to environment factors, conditions that determine performance and the ability to survive. The greater the diversity, more survival is expected, and that is the sustainability. Low diversity or monoculture creates uncertainty against any infliction of any biotic or abiotic stress, resulting in deprivation of food production and thus threatening the food security. In Pakistan, there was only one banana variety, Basari. When attacked with the virus, 90% of the crop was wiped out completely, and if there have been diversity, there were chances that some would survive and there must be some option, but there was no option being only one variety and it was threatened food security. Pakistan is blessed with the enormous diversity in plants and it needs to be conserved as it is threatened by perils of mankind, particularly the land use change, converting the agriculture land into cities, industries, and other usage, replacement of many diverse land races with fewer improved varieties, practicing monoculture and non-technical methodologies like over-harvesting, wastage, and climate change. There are various strategies of conserving the plant diversity. One is the conserving in its own habitat, that is in situ conservation, and the other is conserving in a place outside its habitat, that is ex situ conservation. Pakistan Agriculture Research Council is the apex body catering the need of research and development in agriculture at national level with coordination and collaboration with international and provincial institutions. Under the leadership of PARC, the Bioresources Conservation Institute at National Agriculture Research Center Islamabad is mandated with the ex situ conservation of plant biodiversity under the Plant Genetic Resources Program. Besides, BCI has two other programs, that is National Herbarium, which lists and records the flora of Pakistan and deals with the classification and identification of plants. Without correct identification of plant, the whole results becomes baseless. The other program is the Microbial Genetic Resources Program, dealing with the conservation of microbial genetic resources and its use in agriculture enhancement and product development. The Plant Genetic Resources Program is associated with the National Gene Bank of Pakistan, which conserves the seed of 350 plant species, including the plant genetic resources for food and agriculture. To date, it has conserved more than 42,000 accessions. The National Gene Bank distributes the germplasm to breeders and researchers in the National Agricultural Research System for crop improvement and diversification, contributing toward the food security.
Establishment of gene banks around the globe took place in 1960s when, due to onset of Green Revolution, land races began to replace by modern varieties. In Pakistan, exploration and collection activities were started in early 1970s when rice germplasm was collected under PL480 project. However, with the establishment of Plant Genetic Resources Institute in 1993, it gave a strong boost to PGR collection activities in Pakistan. Until now, more than 140 germplasm collection expeditions have been sent to different parts of the country, and substantial diversity of cultivated crops have been collected. Total germplasm status in the gene bank has now reached to 42,000 accessions. Exploration and collection are the major source of germplasm acquisition for gene banks. Before sending any exploration collection mission, we need to keep in mind important considerations. For example, What is the objective of this exploration mission? Is it meant for pre-assessment or collection? Do we have enough preparations beforehand for that particular species or target area we are traveling to? Do we have appropriate stuff to deal with post-collection handling of the germplasm in the field? Do we know how to check the quality of material in the field? Similarly, if we are going to collect seed from trees, do we have specific tools that will be needed? For example, pole type, scattiers, portable ladders, large seed collecting sheets, etc. Keeping in view these considerations ensure good quality germplasm collection. Seed processing is an important step which enables curators to have good quality seed for banking. Once the seed arrives in the gene bank, it is processed according to type of material collected using specific tools and equipment. Seed processing may include seed extraction, threshing, cleaning, washing and drying depending upon type of seed in hand. Infected or damaged seeds are removed and only healthy seeds are further processed prior to deposition in the cold rooms. We encounter different kinds of seeds and we need to handle differently and carefully without damaging the seed. Proper labeling at each step is mandatory to avoid any mixing due to mishandling. Viability testing is a mandatory step before subjecting seed to low temperature storage after allotment of accession number and location in the gene bank. The material with high germination rate is subjected to accession allotment and subsequently stored in the gene bank. Different methods are used for germination testing. Normally between paper and top of the paper method is used in the national gene bank. In between paper method, seed is sandwiched between two layers of moist paper towels, then rolled and placed vertical in plastic beaker, covered with polythene sheet to protect the paper towel from drying, and finally placed in the incubator. Top of the paper method is used for small size seeds. Seed is placed on the top of moist paper towel or blotter in a petri plate, and then petri plate is covered before placing it in seed incubator. Germplasm sharing for promoting research and development work for crop improvement is one of the important objectives of the gene bank. Gene bank supplies 8 to 10,000 entries annually to National Agricultural Research System. We receive completely filled in seed request form along with standard material transfer agreement for processing seed request. Seed distribution process takes around 1 week to process the case and dispatch the seed. This involves number of steps, for example, preparation of accession list, looking its location in the database, retrieval of seed bottle from the gene bank, listing seed bags, labeling, preparing dispatch letters and handing over the material to courier. National Gene Bank also provides feedback pro forma along with seed to end users for seeking their valuable suggestions to improve gene bank services.
Plant Genetic Resources Program has undertaken the task to collect the PGR from all over the country from diverse ecologies, conserve and distribute it to the present and future use. Since no country is self-sufficient in genetic resources, PGRP acquires exotic material from abroad and ensures safe introduction observing the quarantine procedures. The various laboratories in PGRP undertake complex SOPs of seed processing, enabling seed banking for mid-term conservation of 50 years cycle and beyond. The germplasm is extensively evaluated in field and lab to identify desirable traits for crop improvement. The information of each entity, right from collection to distribution, is managed. The gene bank distributes around 10,000 samples annually to its stakeholders in the NARS, which has resulted in the development of many varieties, elite lines with traits of interest for breeding programs. Hundreds of PhD and postgraduate thesis research contributing in the national food security and in the development of HR to the future action with innovation for food security. The gene bank also serves as the repository for the reference samples submitted for varietal registration at the Federal Seed Certification and Registration Department serving the seed sector. BCI's director also served as the national focal point for the International Treaty of Plant Genetic Resources for Food and Agriculture of Food and Agriculture Organization and coordinates activities on implementation of the international treaty.
In vitro conservation activities in our institute are related to conservation of vegetatively propagated crops, which cannot be conserved as seed either due to their heterogeneity or recalcitrant behavior. It is an advanced technique of ex situ conservation to preserve important genetic material. In this technique, we use vegetative parts of plants such as shoot, meristem, and embryos for germplasm conservation. This conservation depends on principle that plant cells are totipotent and plant material can be kept alive for long period as in vitro cultures. In our lab, major emphasis is being given on research to develop appropriate methods of conservation of potato, sugarcane, sweet potato, grapes, and banana crops. In this technique, the emphasis is given on slow growth culturing techniques at lower temperature or the application of growth retardant in culture media to increase the subculturing period. First, healthy explant is collected from field, and before establishing in vitro cultures, these explants are surface sterilized using various concentration of sodium hypochlorite and ethanol. After that, these explants are inoculated on culture media. For different crops, we use different medias having different concentration of growth hormones and growth retardants for optimal growth. After establishing in vitro cultures, these cultures were continuously subcultured for longer preservation.
Plant genetic resources play a vital role in crop improvement and food security. Germplasm evaluation is prerequisite for utilization of plant genetic resources to develop high-yielding, improved varieties resistant to diseases, insects, pests, and resilient to climate change. Evaluation Lab of Plant Genetic Resources Program conducts germplasm evaluation for agronomically important traits. Germplasm evaluation for agromorphological traits is conducted in the field using standard crop descriptors. Seed multiplication of germplasm is also a regular activity for seed rejuvenation. Germplasm is also evaluated for biochemical and molecular markers to study genetic diversity. Seed storage proteins and rapid and SSR DNA markers are used to study the genetic diversity in plant genetic resources. Seed storage proteins electrophoresis is conducted in the lab using SDS page method. Seed storage proteins are extracted from the seeds of different germplasm accessions and separated through electrophoresis on the basis of molecular weight. On the basis of presence and absence of different proteins, genetic diversity in the germplasm is studied. For using rapid and SSR markers, DNA is extracted from fresh leaf of seed samples from different accessions, and PCR analysis using random or specific primers is carried out to study the genetic diversity in germplasm.
Riutilizo. Faccio tutto che
On the basis of germplasm evaluation, selection of elite germplasm lines is made for utilization in crop improvement programs.
The Plant Introduction and Seed Health Lab is charged with acquisition of exotic germplasm and indexing the health status of material stored in the gene bank. Avoiding contamination by pathogens and pests is essential in managing plant germplasm. In addition to imposing quarantine, it is also a necessity to avoid cross-infection during multiplication. Introduced germplasm as well as the conserved seed stocks are examined for contamination by pathogens and pests. Registering the health status helps in avoiding the spread of pathogens to new geographical regions. New seed-borne pathogens, especially viruses, have been detected in the lab in the material even coming from international agricultural research centers. The Seed Health Lab also investigates the propagation methods to get healthy seeds from contaminated lots. Plant Introduction and Seed Health Lab is maintaining locally collected as well as exotic medicinal and aromatic plant germplasm. Keeping in view the status and potential of essential oil industry, facilities were established for the extraction of essential oil through steam and hydrodistillation process at small scale from mint germplasm. Essential oil extraction is being carried out from basil, rosemary, lavender, oregano, thyme, geranium, and other medicinally important aromatic plants. Distillation unit of 20-liter capacity for the large-scale extraction of essential oils and hydrolates is also working. Characterization of chemical constituents of essential oils is being carried out through TLC, GCMS, and HPLC in collaboration with different labs. Cinnamic acid and caffeic acid derivatives from basil plant extract were found promising for cancer cell death in leukemic patients. Likewise, fungal pathogens are being continuously isolated by screening of germplasm preserved in the gene bank of PGRP BCI. Essential oils and plant extracts of different medicinal plants were tested for management of seed-associated fungi as an alternate approach.
Thank you so much, Dr. Tariq. And actually, it was a very important points for us about the bioresources and the Conservation Institute and the National Agricultural Research Center, and also it gives us an overview for very important steps, step by step, how can we go for conservation from the seeds up to we come up to duplication, and also disease detection up to very high level. And this is very important for us to know the capacity of the conservation in Pakistan, which I know that it is really high and popular. Before we go back to Dr. Minora, because I think now this is have been solved, the technical issues. I would like to remind all of us, all the participants, to please finalize the questionnaires that have been sent to you before, and try to submit it today. We need it before the end of the activities today. So please send us the questionnaire, and Now I need to give the floor for Dr. Minora Snibikova and from the Gene Pool group of Kazakh Research Institute of Agriculture and Plant Growing. And Dr. Minora will give us an overview on gene bank in Kazakhstan and Central Asia. Dr. Minora, the floor is yours.
Ну, видео включить.
Госпожа Минора, мы вас слышим. Можете включить видео.
Видео что-то не включается. Так. Отключили демонстрацию.
Демонстрация экрана отключена.
Почему-то отключена демонстрация экрана.
Нет, нет, у вас есть разрешение, все участники.
Так.
Попробуйте еще раз.
Сейчас. Начал. Слышно, да?
Да, слышно.
Dear colleagues, thank you very much for opportunity participating in this training webinar. Let me introduce you with a presentation. Включи, пожалуйста, презентацию. Первый есть. Первый. С самого начала. Ага. Ну как это? Это ты в конце. Вот первое. Нет. Первое. With presentation biodiversity of plant genetic resource for food and agriculture in Kazakhstan Republic. Второе. Следующий.
Госпожа Минора, вы не могли бы расширить экран? Прошу прощения.
Да, я тоже хотела сказать.
Расширить экран вот.
Сейчас вот. Значит, let me introduce you with presentation biodiversity of plant genetic resource for food and agriculture in Kazakhstan Republic. The second. The research with genetic resource was started in '96 in our republic when disrupting a former union, but funding the project were started in 2001. For these 10 years, we have 10 projects which were devoted collection, evaluation, conservation, documentation, genetic resource for sustainable development of agriculture in Kazakhstan. We also participating in international project for 2 years. 2 years we work with USAID, Washington State University in CIMIT project for plant exploration in Kazakhstan and collected wheat and barley genetic resource for crop improvement. And the second project was devoted improving the sustainability of winter wheat yellow rust using conventional and molecular genetic approaches. We're also participating in one project of devoted conservation, documentation, and utilization genetic resources in Central Asia and Caucasus, which funding with Australian Center of Agriculture. GTC CIMIT project was devoted demonstration of yield potential of local and foreign winter wheat modern varieties And very important was the project FAO, establishment of national international sharing mechanism on the implementation of the global plan of action on plant genetic resource for food and agriculture. The main directions of PGR research was collection, mobilization, new germplasm, then evaluation them, documentation, and organized storage. We also transfer useful germplasm to breeding program for improvement crops. Participating partners was the experimental station, research institute, and universities of the Ministry of Agriculture and Ministry of Education, our republic. In this slide, you can see the state of plant genetic resource for food and agriculture in our republic, which were in second country report to FAO. You can see that cereal crops mostly is in our collection. The status of ex situ collection were presented mostly by advanced improvement cultivars and breeders line. In Kazakhstan, concentrated unicum genetic resource, 194 plant species determine the genetic potential of 24 crops. You can see genera species, the main genera of wild relatives, cultivated plants of Kazakhstan flora. The wild flora of fodder crops in Kazakhstan is represented by 70 species, 29 genera. This gene pool has a high degree of tolerance and adaptability to stress factors of environment, drought, heat, low temperature, and soil salinity. Zailitsky and Chungarski Alatau, our mountain, the primary and the most ancient source of domestication are apple trees. The structure of DNA of more than 2,000 apple cultivars varieties is identical to the wild apple tree of Sivers. Vegetable agrobiodiversity of Kazakhstan is represented by 70 genera. In the Republic, there are more than 100 species of wild relatives of onions and garlic, including their progenitors species. Medicinal plants of the flora of the Zailitsky Alatau is represented by 13 species of 9 genera, industrial cultures in 15 species of 8 genera. South and southeast regions of Kazakhstan are identified as a secondary center of origins for wheat species Triticum aestium, Triticum compactum, Kujabidai, Kazakh name, Sphericum turbitum, subspecies Polonicum, Triticum dicocum, and wild relative species Aegiopsis grassa, Aegiopsis juvenalis, Trinsicalis, Cylindrica, and Tausche. In Kazakhstan, a progenitor of cultural barley, Spontaneum, was found. Cardium bulbosum is an important tool of modern biotechnology. Bogdani and Brevisium ulatum grow on highly saline soils, which allows to as to use the important sources in breeding for salt tolerance. The species enter the primary, secondary, and certainly genera of wheat and barley. Here you can see expedition which we made for collecting wild species since 2003 to 2015, we made more than 10 expedition and collection more than 1,400 accessions. Since '96, we participation in international variety testing, which organized by two international organizations, CIMIT and CARDA. We also exchange by collection material. We are also participating in exchange of collection material by gene bank of gene banks of Republic of Former Union. It's Russia, Belarus, Moldova, Ukraine, Kyrgyzstan, Tajikistan. From 2012 to 2020, we transferred to research and breeding program for crop improvement more than 4,000 accessions. Here you can see the results of this research. 6 variety of bread, wheat, and barley was realized. 5 variety bread variety was transferred to State Variety Testing Commission. Also to State Variety Testing Commission was transferred apple variety, cabbage, eggplant, garlic, millet. We participating in project FAO National Information Sharing Mechanism since 2004 to 2007. A set of tools included 43 main and 8 additional indicators and information system involving a database and mechanism. In project participate 50 organizations, including 182 contact. We evaluation more than 200 projects. Access to Kazakh mechanism can be in several languages of the world information and early warning on plant genetic resource FAO. For documentation, we adapted the ICARDA system. You can see descriptors of the passport date, which included population type, conservation status, seasonality, and status. Here, to country report to the FAO on the state plant genetic resource of Kazakhstan Republic prepared in '96 and in 2010. inventory in 2018 show that now we have ex situ collection in situ collection more than 6,000 accessions. He appointed the research institute and accessions. We don't have the national gene bank, so you can see the type of storage germplasm in our research institute. He appointed also our storage room where we organize short-term storage +4, +6, and low temperature refrigerator. For low temperature refrigerator for storage very important collection of wild relatives. In this slide, we pointed our problems and solution these problems in work with genetic resource. Our big problem is storage of genetic resource because the dominant type of collection storage is short term. So we can see decrease in viability up to 13%, loss of valuable material, many important collection inadequate, duplicated. The problem that carried out by genetic resource in the agro-industrial complex of Kazakhstan Republic, it's first environmental protection and reproduction of natural resource, diversification of crop production, pre-breeding, transfer of promising forms. He pointed directions and effect. State support measures. The Ministry of Agriculture of Republic has repeatedly emphasized the importance of PGA for food and agriculture. However, until now, questions remain open on development. At first, development separate budget program for the conservation, evaluation, and use of genetic resource. The second, a stringent of coordination and state registration of collection and enhancement the legislative framework for genetic resource, construction of the National Gene Bank. Thank you for attention. I'm sorry about my English. I don't have enough practice.
Thank you, Doctor, for your presentation, Dr. Minora, and your English is fine. We were okay. We were following up your presentation. Thank you very much. And the discussion will be in the end of the session. So now we will move to Oman, and our speaker, he is a plant geneticist and in the natural and the medical sciences research centers in the University of Nizwa. Our speaker is Dr. Ali El-Lawaki, and he is going to give us a lecture on plant introduction and quarantine. Dr. Ali, the floor is yours. Ahlan wa sahlan.
Thank you, Doctor, for introducing me, and thank you for the organizer and, of course, Professor Siddiq for letting me to present about an important issue of seed management, plant genetic resource management, which is the seed health and quarantine. And I will share my presentation now. So, is the presentation in front of you?
Yes.
Okay, thank you very much. So, the presentation will have, in fact, just a moment. The presentation will have three main outline: seed-borne pest and seed health testing concepts, seed health testing methods, and management of seed-borne pest. Of course, about half an hour ago, we saw from the National Gene Bank of Pakistan activities about the issue of the seed health presented by shortly by Dr. Tahira from the National Gene Bank of Pakistan, and this of course training it and but I felt that this is important to share with you as well, and because I think this is important information excuse me, to build on. So we are going to talk about the seed-borne pest and seed health testing concepts and seed health testing methods. So the gene bank operations, as we listened earlier by Professor Siddiq and other colleagues, that the objective is to handle seed genetic material for research and development. And of course, so it has several steps. First of all, collection of indigenous germplasm of all socioeconomic plant species in Oman. Our gene bank is not only concerned with the food, but also with the crops that has other socioeconomic values such as medicinal plants. Of course, acquisition, as discussed earlier, that acquisition of plant introduction from outside is very important for research and development, because sometimes the material that within the country is not sufficient for breeding objectives, for example. Then the quarantine and seed health is very important as well, which is after you receive the seed either from inside the country or outside the country, you need to go through this procedure. And in fact, our presentation will based only on this stuff. Then, of course, conservation of the indigenous germplasm. Of course, then characterization of indigenous germplasm or whatever materials that you do have. And then, of course, database management, which is in fact covered very nicely by presentation by Dr. Rafiq and his colleagues. So objective of the seed health testing has in fact several, but for example, the first one is to prevent spread of the disease, seed-borne diseases, and of course to minimize the risk of accidentally introducing exotic pests and pathogen into other countries or even within the countries to another regions within the country, and of course to improve the seed stock and certification scheme, because when you are exporting seeds for research and development, you need also to have such kind of certificate system that your material is clean from pests and pathogens. And of course, also to satisfy quarantine requirement of the recipient country, because sometimes the recipient country has, for example, will not tolerate for any type of pest or pathogens on a particular species of food or agriculture or whatever species. So that should be also taken into consideration. And of course, because the gene bank, when it's sharing its material, it's of course exchanging that material should be grown healthy, not infected or infested by any disease or insects. So this is very important to know that this value of this material that we are sharing with others is really good. And then also to know the storage quality, the quality of the storage of the seeds, of course, for the seeds that are conserved in the short conservation storage, which is five might be to maximum 10 years, are in good quality, especially this is for the orthodox types of seeds. And then of course check the advisability of treatment. Do this seed needs particular treatment before and before sharing with others, or before we are getting the materials to the gene bank. So types of pests and pathogens, these are classified to microorganisms. For example, fungi, omocytes, bacteria, viruses, viroids, virus-like organisms, phytoplasma, protozoa, nematodes, and parasitic plants. The other type is what they call it ectoparasites, such as insects, mice, and vertebrates, or other pests that affect plant health by consumption of plant tissues. Of course, we are dealing here with the seed-borne diseases, which is causing, the material that the gene bank usually are dealing with, which is the seed-borne. Of course, there are other types of infection sourced from soil-borne or wind-borne or insect-borne diseases. But of course, we are dealing only with the number one, the seed-borne. So time of seed infection. Seeds are attached by various stages. Could be the seed is take this pathogen or pest from the mother plants during its growth of the mother plants, or during processing through cleaning and threshing the seeds or taking particular measurements. It may also be infected or infested. Also at the time of transportation, especially if the transportation is from long distance to the gene bank, and of course during the storage. Of course, with the proper storage, we should, and if the materials is clean when enter to the gene bank and processed very cleanly, then should be the proper storage should really reduce this kind of infection. So types of seed transmission, contamination of the seed coat with the pathogen, resulting in subsequent infection of the germinating seedling by mechanical means. So the pathogen, what they call it, enter through the coat to the endosperm and the embryo of the seeds, or the pathogen is found within the tissue of the embryo. So it was within the embryo, and the embryo may become infected through the ovary or via the pollen. And here an example of kernel bunt and on cereals, and we can see that this is very clear. I mean, this seed lot has infected with this this fungi and should be really cleared and should be eradicated, not enter to the gene bank system. Seed-borne pathogens, implication for risk analysis. Um, um, of course, the implication for the analysis, including epidemiology of the pathogen, alternative sources of inoculum, in-field control measures, and threshold for seed-borne inoculum. So for the epidemiology, we would like to know the potential of for seed transmission of that pathogen or condition of disease development and spread, and then how we can eradicate or manage this pathogen. Alternative sources of inoculum. Is it from residues, infested from residues, or soil-borne inoculum, or infected from other crops or weeds within that field of the gene bank, or excuse me, of the genetic material that we are going to conserve. Control measures. Are we dealing with the resistant cultivars as genetic material? What kind of fungicide that we may use? Are these materials are going to be within crop rotation or were taken from a crop rotation or not? So such kind of information is really could be helpful for to know that this seed may have seed-borne pathogen or not. Of course, these are factors that help or very important for the potential for seed transmission of the pathogen. For example, environmental factors including temperature, moisture, light, pH, soil microflora, and degree of internal infection of seed. Genotypes, are we talking about resistant genetic material, or we are going are we dealing with the pathogen that is really resistant to the chemical treatment or fungicide treatment. Of course, inoculation potential, amount of inoculum, and conduciveness of environment that also may increase the potential of this. That seed has the pathogens. The transmission rate, is it slow? Is it high? Threshold for seed-borne inoculum, what the minimum, what the maximum to avoid this seed transmission of pathogen, and then complex lack of adequate field research. So the reason for seed health testing is to determine quality of the seed based on several seed quality attributes, to provide basis for price and consumer discrimination among seed lots and seed sources, and to determine sources of seed problem, thereby facilitating any corrective measures. For example, applying fungicide or fumigation for controlling insects, for example. And of course, to fulfill legal and regulatory requirements for certified seed classes, because when you are sending or exchanging seeds, the seed need to be really certified. And as discussed earlier, that also to satisfy the requirement of the important country or recipient country. So there are several seed health testing, and these in fact were based on International Seed Testing Association, International Seed Health Initiative, and for another one, the National Seed Health System of the United States. And this will be really information for you for the gene bank, that how to develop their methods for quarantine and for seed health system procedure. So to know which health tests are good for you, for your gene, for the gene bank management and for quarantine, of course it depends on different factors. And for example, specificity, which is the ability to distinguish the target pathogen from all organisms likely to occur on the seed from the field or the store. So we are and we have a specific pathogen or insect that we are looking for, that we need to avoid it to enter the gene bank the gene bank system. And this is of course also will help us to avoid false positive. That is, we are anticipating that this is infected with particular pathogen, but in fact is not. Speed. So this is the case that we want accuracy, but we may reduce the accuracy a little bit for rapid result. But of course, this is based on the on the gene bank curator, as well as on the seed health scientist who can judge this. Simplicity, of course, we are looking for simple method for getting the target pathogens or infects or insects or pests in general. And of course, this is one characteristic. Of course, uh, that need really resources, human resources, scientists, technicians, chemicals, and things like that. And of course, reliability should be robust, and also we can, of course, repeat it whenever and within this, and we can get the same probability of results, statistically probability that are not varied from time to time or from one person to another person. And of course, the pathogen have important characteristics, of course, depending from which kingdom that we are dealing with. Is it homicides or fungi, bacteria, or viruses? And how it's localized in the seed? Is it within the seed, over the coat, or within the embryo or tissue of the seeds? And how the transmission of the born disease is coming through, to the seeds. And then, of course, here is an example, for example, for wheat. This is, quarantine organism that might be, there is no tolerance for such fungi to be within your material that you receive from outside. Of course, seed health testing are several, and this is an example that I had it from Icarda 2 years ago. And dry seed inspection, visual examination, which is the easiest and the rapidest one. Growing on test, this is may take like 6-8 days to check the seed if it has some disease or not. Indicator inoculation test, centrifuge washing test, agar plate test also may take some days. Freezing plotter test, as I remember, it is taking 1 day. Embryo test might be also 1 day. Nematode extraction also test is 1 day as well. Serological test, ELISA, tibia. These are really specified techniques. And of course, the last one is molecular test, which may take a couple of days, 2-3 days or maybe even might be within 1 day, to get if the pathogen are within the seed material that you had from outside the country. So this is the last slide, and as I said, this is the presentation were adapted from training documents from ICARDA, from Dr. Safa Kumari, and thank you very much. And yes, thank you.
Thank you, Dr. Ali, so much for the presentation about plant introduction and quarantine. It gives us also an overview step by step for the whole methods that it is used for seed conservation and also disease, and how can we keep our seeds really healthy. And we will expect a lot of also questions in the discussion and the conclusion. So our thank you, Dr. Ali, so much. Our next speaker is Ms. Shinai Boiraz Tubaloglu, and she is the head biodiversity and genetic resources department in Turkey, and she will present for us gene bank management in Turkey, standards and challenges. Ms. Shinaya, I hope I'm pronouncing your name properly. The floor is yours.
Thank you, Mr. Abdulhamid. It's okay, the pronouncing of my name. My name is Shinai Boiraz Tubaloglu, and I'm going to share my presentation now. Distinguished participants, I greet you on behalf of the Field Globe Central Research Institute from the Ministry of Agriculture and Forestry of the Republic of Turkey. I am honored to participate in this training and to be among you. I hope the meeting will be beneficial for future collaborations and joint projects. I'm head of biodiversity and genetic resources department, and my presentation name is Gene Bank Management in Turkey, Standards and Challenges.
Yes. Microphone.
I would like to start with a summary of Turkey's biodiversity focused on plant diversity, and then management of genetic resources and institutional structure for XP conservation in Turkey. Later, I will introduce seed gene banks and present our workflow, standards, and challenges. Turkey has a global importance in terms of agricultural biodiversity.
Shinai, can you try to improve the voice quality now? Maybe you open the window or something like that, because we hear some noise around you.
Okay. I will try without microphone. It's okay, Mr. Chair? Is it okay?
Yeah. There's additional voice or sound?
Like a window or something?
Yes.
Okay. Yes, please.
It's okay?
No, it's only one.
Okay, please continue.
Turkey has a global importance in terms of its rich agricultural biodiversity and genetic resources as elements of biodiversity. This richness mainly due to its topographic diversity, climatic conditions, and hosting the elements of three phytogeographic regions, as well as its natural flora and fauna. In terms of agricultural biodiversity, Turkey has a regional and global importance of located in the region where agriculture originates. With nearly 10,000 species of vascular plants and ferns, Turkey has the richest flora of any country in the temperate zone, with a level of endemism of almost 33%. Archaeological studies show that the Fertile Crescent, which includes southeastern Turkey, is the center of origin for agriculture. These areas still host the crop-wild relatives of many food plants. Wheat, barley, lentil, chickpea, pea are some of the first agricultural products of human being. At the beginning of the last century, 5 primary gene centers were identified by Vavilov. Turkey is located at the intersection of 2 major Vavilovian gene centers, the Mediterranean and the Near Eastern gene centers. Also, Turkey has microgene centers for many crops. The map shows the 5 macro centers of genetic diversity for several crops and fruits. Wheat, which is one of the top 3 plants that meet the food needs of the world's population, Turkey is primary genetic diversity center for the Wend races and wild relatives of wheat. The wheat taxa you see are the progenitors of modern wheat, and they are all naturally grown in the flora of Turkey. Why are centers of genetic diversity and their ex situ and in situ conservation so critical? Sustainable Development Goal 2 is Zero Hunger, which is to end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. SDH2 sets out 5 key targets to be achieved by 2030. Target 2.5 says, maintain the genetic diversity of seeds, cultivated plants, and domesticated animals and their related wild species. Plant genetic resources are playing an ever-growing role on world food security and economic development. They underpin the ability of agriculture to cope with environmental and socio-economic changes. We conserve these genetic resources, which are a treasure for food security of our country and the world. In Turkey, there are 32 gene banks affiliated to institutes under the General Directorate of Agricultural Research and Policies. GDAR, under the Ministry of Agriculture and Forestry, is the institution responsible for the collection, conservation, and management of genetic resources in Turkey. Currently, about 32,000 germplasm accessions are conserved in ex situ collections of TAGAP, General Directorate of Agricultural Research and Policies. You can see in the map the current status of ex situ collections across Turkey. Turkey's ex situ collections have 90,000 animal genetic resources and 50,000 fishes, over the 100,000 plant genetic resources in seed gene banks, and about 10,000 vegetative genetic resources in field gene banks. And now I would like to present the studies of our seed banks. The collection and conservation of genetic resources in Turkey started at approximately the same time as the world. The first gene bank in Turkey has been established in 1964 in Izmir. It's National Seed Gene Bank, which has more than 55 accessions. Second is the Turkish Seed Gene Bank, which I also work for, and under the Field Growth Central Research Institute, is located in Ankara. It has been founded with its modern infrastructure in 2010 and is one of the biggest capacity gene banks in the world. It currently has more than 60,000 seed samples. Turkish Seed Gene Bank has several departments to achieve workflow of gene banks. And also we have 2 laboratories and climate chambers for our research projects. Our team consists of agricultural engineers, biologists, technicians, laborants, and workers. Continuing in their academic career, the technical team also works as a researcher and leaders in the projects. The preservation of reference herbarium collections in gene banks is also important. Our herbarium has a capacity of 60,000 samples, and the existing samples have been digitized and can be free accessed via website. Turkish Seed Gene Bank was designed with suitable facilities for drying, packaging, and germinating seeds at international standards. Currently, previous standards are implemented in accordance with technical and human capacity. The workflow you see is followed step by step. Of course, gene banks have a number of challenges and institutional solutions should be applied in gene bank management. This is the first step, acquisition. Acquisition by collecting or donation of material entries to gene bank. The management of plant genetic resources needs systematic collecting of germplasm. The ways to acquisition are field collecting, exchange with botanic gardens, or gene banks donations from individuals or NGOs or academic researchers. The aim of germplasm acquisition is to collect materials with maximum amount of genetic variability. Of course, within a strictly limited number. Collecting strategies should be established to ensure maximum use of time and resources for distinct populations and geographic location. There are some difficulties and challenges to be aware of in gene bank management. I would like to put forth challenge in places. Gap analysis should be performed for time and resource usage, and the breeding system of the target species may be taken into consideration in order to define the number of plants to sample within a population. And breeding biology of target population, if possible, according to breeding biology, if possible, harvest seeds from at least 30 for cross-fertilizing species and 60 individuals for self-fertilizing species. And of course, passport data and associated information should be collected and documented. A standard collecting form is helpful to collect the associated data for each sample obtained, and each sample is assigned a collected number, so the samples can be linked to the collected information. We conserve, orthodox seeds in gene banks, and they will survive drying and freezing during ex situ conservation, and can be preserved in seed gene banks for medium and long term. Seed processing before storage involves cleaning and drying. Moisture content determination and viability testing are necessary. Packaging by airtight containers and storage of seeds are necessary to maintain quality of seeds for long periods. And two types of seed stores are used for conservation of genetic resources, base collections for long-term and future use, and seeds will not be distributed from base collection directly to users, but only used to regenerate active collection. A suitable temperature for long-term storage is minus 18 degrees Celsius. Active collections consist of accessions which are immediately available for multiplication and distribution for use. Active collections at a temperature of 5 to 10 plus or minus Celsius degree. Turkish seed gene bank storage facilities consist of 6 cold rooms, 2 for long-term, 2 for medium-term, and 2 for short-term working collection. The gene bank management system should include tools to monitoring seed viability and report it when regeneration is required. Regenerating when the viability drops below 85 of the determined threshold or insufficient number of seeds for long-term storage. The time, budget, and infrastructure required for regeneration are related to the breeding biology of target species. Germplasm regeneration is the most critical operation in gene bank management because it involves risks to genetic integrity of germplasm accessions. They due to human error, selection pressure, outcrossing, and mechanical mixtures, gene mutation, and genetic drift, of course. In Turkish seed gene bank, we regenerate over 2,000 crop materials per year, especially wheat and barley. We have 2 production areas. For species need different ecogeographic features. Collaboration with other institutes is needed. Regular monitoring of seed viability ensures the quality of seeds conserved and distributed. It's important to use standard protocols. Many gene banks have developed protocols. Several resources can be found online on these websites. In viability testing, seed amount for some exceptions could be a challenge. It's recommended to use a minimum of 200 seeds as 2 replicates of 100 seeds, but this is not always possible. In Turkish Seed Gene Bank, we use 100 seeds as 4 replicates of 25 seeds for critical amount exceptions. Another step of workflow is safety duplication. Safety duplicates are generally conserved at a different location for minimized risks. As I mentioned before, there are 2 seed gene banks in Turkey, and they also act as a duplication centers for each other. Each safety duplicate sample is accompanied by relevant associated information. It's a limiting factor that safety duplicates are usually need regeneration for sufficient amount for duplicate. The process of germplasm distribution is governed by national and international regulations. As a signatory to the treaty, we use SMTA, Standard Material Transfer Agreement, for material exchange. For most species, a sample of 100 to 200 viable seeds are supplied to the researchers that's supported by official projects. For some species and for some uses, a smaller number of seeds is sufficient, or regeneration is needed. There are legal regulations for material transfer abroad, such as import permits and phytosanitary inspections. Characterization is a necessary step for effective use of gene bank material. If possible, it's recommended that characterization data should be obtained as soon as possible after accepted accession. The use of standard crop descriptor list is recommended. A wide range of crop descriptor lists have been developed. For example, by Biodiversity International, the International Union for the Protection of New Varieties of Plants. But it's not always possible to obtain characterization data at the first step. Many collections in gene banks are poorly evaluated, and development of whole collection concept is usual for rising use of genetic resources. A gene bank information management system is developed specifically for your gene bank, or one of the several systems available is used or adapted. All data and information, including images, should be validated and uploaded to the gene bank information management system. Data is duplicated at regular intervals and stored at a remote site. Sustainable gene bank management requires well-trained staff with clearly defined responsibilities for accession management. As a conclusion, the gene bank management has more than 50 years of knowledge involved, and changing environmental, economic, and ecological conditions and increasing research results require following scientific developments and updating. National, regional, and global collaboration have become increasingly important in overcoming the challenges. And of course, training, planning, and accompanying legislation and policy should be our priority at national and regional level. Thank you for listening. Thank you.
Thank you, Ms. Shinai, for the important presentation. Actually, this was our last speaker today, and if you allow me now, we will join our colleagues and Dr. Sadruddin Siddiqui for our discussion and the conclusion remarks today. So so Dr. Sadruddin, we are both together now for the discussion, and we are opening the floor for all our participants for questions, comments. The floor is open.
Thank you very much. First of all, I would like to thank you for this moderation and all the participants who resource person gave good presentation. And in the last, the presentation from the Turkish side, they have in the end listed the collaboration and regional cooperation is very important. And I think that this is the main theme of this session, that we have to develop collaboration and coordination among different gene banks and regions so that we can improve together to attain the goal of conserving germplasm in a better way by learning from each other and develop cooperation for food security in the OIC member states. So I think that if the participant could give some information in the question answer section, that what are the strengths of their activities. For example, some gene banks are very expert in evaluation, molecular evaluation. Some has more experience and expertise in field evaluation and characterization. So if we can have this knowledge, then we can contact these persons from different gene bank to have training arranged. Also, when we next arrange some training, we will invite them as resource person, or if we can do in person, not virtual meeting, but training in person to some places, then we can have choice where to arrange the trainings. So it would be a good idea if the...
It is a very good idea indeed, Dr. Sadruddin. Actually, it is very good idea. I think we have also to take it into consideration during our current training courses, or also during the next sessions also, that the participants also can explore. If you allow me, Doctor, there is a question, so we can give the floor to Dr. Samia Taslim. Okay, and Dr. Ali, then we will give you the floor, but we will give now to Dr. Samia. Samia. Yeah. Unmute and speak.
Assalamualaikum. You hear me? Yeah, my question for the all respective organizers. I'm developed to certain product, to value-added product from plant sources to the drug discovery. So kindly could guide me how can contact the contact person to develop, to mature these products or commercialize these products?
If you allow me, before giving the floor to answer, actually to commercialization, we have to go through several activities in the laboratory and also in plant variety protection or whatever you have. So your product have to be very well characterized and also to be legally protected before the commercialization. This is from my point of view, because plant breeder rights is something very important in the law. But now, of course, the floor is open for our eminent speaker this morning to answer, Dr. Sami. anyone have from our speaker, Dr. Sadruddin, maybe you have something to comment here.
Yes, I think that each country has a department. Like in Pakistan, we have IPO, Intellectual Property Organization, and they patent the things. So they should, the scientists should contact with those departments in their website and see what are their requirements for patent. And sometimes there is some registration department other than, for example, we have DRAP, the Drug Regulatory Authority. So if they are making some drug, they have to register with that also. So I think they have to go for registration and as well as for patent before they can commercialize their product. So they should look into the net and they can find many information.
Can I comment in addition? I have the patent from 2016. I'm working for these product development 2003. So my product is mature and application of this product is very good. So how can guide me to the commercialize for these products?
Dr. Samiha, if you allow me, Dr. Sadruddin, Dr. Samiha, for registration, you have to know that it is also regarding your institutional legalization. Because if you're working in governmental identity, you have to go also for your office for commercialization. Your office have to help you. Because in universities and the national governmental institutes, there always a commercialization office. And we could not, as a scientist, to go directly for commercialization. So I don't know in your case how it works. But also, this is from my point of view. But Dr. Sadruddin and the other also speakers, if you can have any comment, Dr. Sadruddin.
I think they have to find some partner who want to invest in them. There are public-private partnership or some other joint venture they have to go where they can make the product and it can be upscale for marketing. So they have to find a partner for that public-private partnership. So I think this is all enough for this question, and we should move to some next question.
Next question, please. Dr. Ali, you had something to comment or yeah?
Might be at the end of it's a comment, not a question. So after the audience having their questions, I will just make a comment.
Okay, fine. So if you allow me, till we have some hands raised, you can use the raise hand option if you need a question, please, any participants. So we have this, if you can allow me to pose a question. Dr. Ali, let me ask you. In Oman now, in the as you give us an overview for this gene bank and how this conservation system, how far you interested also in some of wild plants? Because I know the architect of the country, some part of desert, some part has the mountains, some very close to the shore, and each part of this has its own capacity. Like if it's this wild plants close to the shore, maybe it can be salt tolerance, and maybe when it's far a little bit, maybe it will be drought tolerance, and in mountain sometimes it's cold tolerance, and it is a huge variety. I know in Sultan of Oman. Well, I just know, but I don't have deep knowledge. So if you can give us this, how it's reflect your work.
Yeah, thank you very much, Doctor, for your question. It is very important question. Oman has almost 1,400 species of plants. 1,000 of them are really have what they call it socio-economic importance. And for food and agriculture, there are about 100 species. But for example, medicinal plants, we do have like 440 species. And these are all considered as socioeconomic important species. The gene bank that in fact two institutions are working on it now. They are in fact they want to have conservation all of these plants. And of course, when when we are dealing with the national system, usually it has more burden on the conservation, because each seed type, though they are orthodox, it may need some particular type of conservation, and of course other procedure like seed viability, seed test, germination test, and of course the seed health. So we as a gene bank, we are really started very recently, like 3-4 years now. We do have a seed gene bank, and we are starting to collect for example, beside the food species, we are collecting medicinal plant species. And of course each will go through the procedures of the conservation, from germination test, viability test, seed health test, and to the conservation. Of course, if we are talking about we start to accumulate the germplasm in our gene bank, and it is of course a continuous project. That's could be my answer to your questions. If
Yeah,
I
thank
missed
you.
something,
Thank
I
you.
yeah,
Thank you.
yeah.
So you are taking this into consideration to
Yes.
collect from very wide, yeah.
Yeah.
Okay. And you are going to planning also to coordinate in the breeding system. You have
Yeah.
to.
Yes.
Okay. Thank you very much, Dr. Sadruddin. I have question for you. Till we have some other hands raised. Can I?
Okay, please.
Okay, so doctor, if we are talking a very well developed gene bank in Pakistan, and the activities is also ongoing. So how far you cooperating with other governmental and the private sectors that you give to them, you got from them also accessions or helping them in other parts regarding gene banks and the cooperation into government and private sector?
For the time being, we are working with the public sector and government organization, and we are not sharing germplasm with the private sector. But if the private sector give assurance that if they develop some product, they will give to public free of cost, or then we can share germplasm with them. We don't want them to earn money and give no favor to the public. So in public sector, when they use the germplasm, they develop varieties, they give free of cost seed to the farmers. So this is the reason we are only cooperating with the public sector organizations for germplasm exchange. However, for research, we are giving germplasm to all, even abroad, Pakistan, especially the annex crop in the international treaty.
This is clear now. So you can help the private sector for free.
Yes.
This is amazing. This is very important for us to know, and it is very good. I think examples that we have also to consider. So, so Dr. Ali, you need to comment now or in the end? Still now or in the end?
In fact, I have a question to Dr. Sadruddin. Regarding exchange with the private sector. Are you? I think you are also signing with them material transfer agreement as well, and might be conditions like if there is any kind of commercial benefit, the system, the gene bank system in Pakistan also should be benefited. Is that true? If this is true, we would like also, I mean, to share such kind of document, because this will help us in other national countries to see what kind of conditions and terms that we may use for such kind of exchange within the country with with the private sector. Thank you.
Actually, we do sign SMTA with all the people who exchange the material with gene bank, but its implementation is very difficult.
Yeah.
So unless a law is passed by the Senate or some governing body, which make it possible to take the money from the private sector to the community that owns the seed or the research organization, it is very difficult from the private sector. So public sector and research organization, they comply with SMTA. So the access and benefit sharing law is in process, and once it is implemented, then we can go to the private sector safely. So then they will be bound by law to provide benefit and to share the benefit.
Thank you.
Thank you very much. I am back into the floor now. If any of our eminent participants need to communicate or comment, questions for our speaker today. And I have two things to announce. Please, the first questionnaire, try to send it now, because we are really in desperate need for your feedback. And also, I think there is another one. We have to receive it tomorrow, no? Or only one? So we have to please finalize it today, and also we need to receive it. Tomorrow, regarding the MTA that Dr. Ali has just announced it, and how the way we can share a reality approved and things like that, we have tomorrow about the intellectual property rights and plant genetic resources conservation. I think it's also will shed the light for us for very important issues, actually. So this is the will be presented tomorrow by Mr. Ismail, IPO in Pakistan. Tomorrow we have really more variety of speakers. Today was as an introduction, and tomorrow we will go for more details, and we will go for single nucleotide polymorphism genotypes in wheat, very important. We will talk about the pre-breeding of for utilization of plant genetic resources. And there is also, we are trying also to give tomorrow a deep hand-on training for our participants. When we started this kind of cooperation with comstech, actually we are confident, comstech and Iofs confident that this training will be, inshallah, on hand, and we will go together to in situ, and we will visit the gene banks. We will see all this kind of steps in reality, but we have also to keep dua for Allah subhanahu wa ta'ala to take this pandemic out of all of us, and we be safe so we can meet on physical, and we will see. We hope by before the end of the year that we can make this forum on at least partial physical and really online. We hope so. We keep dua for Allah subhanahu wa ta'ala. In the end of today, I would like to give the floor for our lovely brother that we always love to hear him speaking, Dr. Khurshid Hassani, for maybe concluding the day and for any other announcement for tomorrow.
Okay, thank you very much.
And I hope I was not doing bad today. I hope I was fine today and come to be, you know, Excellency, that when we are meeting together, everything is easier. We see each other, we can have body language and we talk, but I know that with Zoom there is some limitation. We keep dua. Professor Hassanin, the floor is yours.
Thank you very much, Ismail. I think it was a very successful session. You conducted it wonderfully. There has been no glitch, there has been no problem, and we hope that the rest can also be going as smoothly. For tomorrow, you've already mentioned that you requested everybody to submit the questionnaires, and so that will enable Sadruddin to make some concluding remarks about the participants and the requirements. And I just wanted to share one new thing, that is we do now have the confirmation from the Islamic Development Bank about their contribution tomorrow. The title of the thing is probably going to be slightly different from what it is written here, but they will be participating. So I'm sure people who are keen to hear what Islamic Development Bank has to share with us. Besides that, the session will start, as you know, at 11 o'clock Pakistan time tomorrow. It's a long session. It will be up till 1600 hours or 4 o'clock Pakistan time. And we will not be able to show the ISDB documentary because they don't think they have it ready yet. So besides that, everything is as we have on the schedule. And so that's all that we have to say. Thank you.
Excellency, so if any, okay, so please come tomorrow on time. We do not want to be late. We need to, because tomorrow is a bit longer day and indeed. And Dr. Ali, yes, we will take care of this on hand. We will keep notes for all what we have received. And inshallah, when we will meet together on physical, we will see how this hand-on training on how can see to keep health. To keep the health of the seed. Thank you and see you all tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum assalam.
Shukran.